Wanted to make a quick video about the rear locker from an 80 series Land Cruiser or the LX 450. These often do stop functioning and will require removal, repair, reinstallation. And I wanted to go over some of the things that are commonly found when people do disassemble them and how to fix it and how to properly time it so it can be reinstalled. On my workbench here, I have an assembled piece and one that's apart, and to show you kind of what it looks like. The number one cause of these to stop functioning is the motor housing has permanent magnets that are adhered to the housing itself. And over time, that adhesive lets go and one or two or more magnets will come in contact with the motor rotor, shorts out the circuit, and then the motor no longer spins. So you carefully need to remove this cap and then assess what's going on the inside. When you do start removing the cap, the best way to remove it is just to leave this cover on and remove the cap. Else you'll end up pulling the rotor out, and then it's a little more difficult to put it back in without experience. So leave this on, this cover on, so it won't look like this. It'll look like this assembled, and just remove these 3 Phillips screws, and you could take the top off and assess what's going on the inside. If the magnet has let go, clean up the surface and glue it back on. Make sure that the layer of adhesive is not thick. If the adhesive layer is too thick, the magnet will come in contact with the rotor and again, not let it function correctly. So keep it as thin as possible, and you can always use calipers to measure the distances. You want the spacing between the magnets to be bigger than the diameter of the rotor, so you can measure those 2 things out. The other thing that occurs in here is just corrosion. Water will enter this either through the breather, which is this little nipple here. It'll come into the housing, fill up, and then things just get rotted out. It can be saved with careful cleaning and then reassembly. And when you do reassemble it, this is the body grease that Toyota does use. This is not a serviceable item. Toyota recommends replacing the entire assembly, but we've come about ways of repairing. So here's the body grease that Toyota uses on a lot of their electrical components to dampen the sounds and quiet the motors. Anyway, inside this is what it looks like on the inside. We have 3 contacts, and we have the shaft that actually actuates the fork for the rear locker itself. The other parts look like this. So this little gear will go down into this housing, and the little gear will be responsible for moving the shaft in and out. The big gear here on this part, this is spun by the motor, so the motor will spin this and then spin the little gear because they're all attached together. And on the other side, we have a spring, and this spring is used in the event that the locker cannot actuate. Instead of keep forcing it, the spring is wound up. That way, when the locker does line up, as you make left and right turns, the spring force will allow it to fully engage. That way, the motor doesn't have to continually run. So again, when you push lock, the motor will start to spin, and it doesn't really care if it's going to engage right away or not. The motor is going to wind up the spring, or if it's already lined up, it's just going to push it right in. So again, the spring is more to prevent mechanical damage to some of these components. Looking at this one, you could see the streaks from the contacts, and you could see these plastic little parts right there and right here. And the way it works is when this is upside down, those contacts in there make contact with this metal disc plate. Depending on the orientation of this disc, contacts are either they have continuity between them or not. So when this is normally assembled, it's going to be in the unlock position. So between certain pins, there's no continuity, and the locker knows, hey, don't spin the motor anymore. When you push lock, this is going to continue spinning until continuity is broken on one of these other rings. Once continuity is broken, the motor knows, hey, I need to stop, and it stops moving the motor. And then we wait for the lock engagement, which would be coming from the sensor inside the rear differential. When you do this, there's a proper procedure for ensuring that the piece is assembled. So when Toyota sends you a brand new one, it comes assembled like this with the shaft out in the locked position, because that's the only way to get the locker in and out. So when you remove the locker, you follow the factory procedures of actuating your locker switch. The locker will go into lock position, and then you could start removing it. So that's why Toyota sends it as a locked assembly. So when you do reassemble it, what you can do, there's 2 different ways. Either you can measure out the distances for locked or unlocked. And what do I mean by distances? Well, you measure the distance from this collar from the top of this collar to the end of the shaft. And what people have measured from brand new lockers is that I think it's 2 7/8 from here to the end of here. So you can see it is now 2 7/8. So if you measure that out, you know that's the locked position. And in order for us to properly time it, is we need to figure out when do we break contact at the locked position. What I have here set up is we can find out what those pins are. And in this housing, the pins go, the top left is 1, 2, 3, and then the bottom row is 4, 5, and 6. 4 and 6, once we lose continuity between 4 and 6, I have hooked up to a multimeter. We know that we lose, we'll get the signal for when the locker is in the locked position, which is 2 7/8. So what I've done is, I have an example here, is I took this disc, I put it onto a bolt, kind of sandwiched it between two nuts, and I'm gonna keep probing it in until I can figure out where that position is. And if you watch carefully, if I start anywhere, you'll hear my multimeter beep when there is continuity. When we don't hear it, we'll know where that clock position is for the locked position. So if I put it in anywhere, if it beeps, that means it's not there yet. And as you can see, it's gonna continue spinning counterclockwise to get the shaft out. So here it's still beeping. If I keep tooth by tooth. So right here, we no longer have continuity. So this is where the signal is going to be initially broken and the motor will stop spinning, and that's where we want it, 2 7/8 out. So if I go back one tooth just to see, we get continuity. Now go back forward one tooth, we don't get continuity. So I'll know that this is how I should probably reassemble the gear and the whole mechanism. So in order to do that, either I can make some marks on the teeth and on the housing, or just remember this position, or you could put it in leaving your multimeter hooked up. And the way you'll reassemble it is you'll have this whole assembly together with the little gear collar facing down. You'll have it like this, and then you'll just carefully plop it in with the orientation you've had earlier. I'll try to do it now the way it was set up. I think I remember the position, and if not, we could always pull it out some. Seems a little more difficult with one hand. All right, there it is. So I got it in the same position I had it earlier, kind of had some practice with this, and I'm not getting any beeping from my multimeter. There's no continuity. That I know that now this is the locked position, and I can reassemble the top. Once it's reassembled, we can hook up a battery to to pin 1 and 2 on the top, either plus or minus plus. I wrote it down right here. To lock it, hook up plus to port, terminal 1 and negative to terminal 2, and you'll start getting the lock. For us, we'll want to hook it up to unlock, so we'll hook up negative to 1 and positive to 2, and the shaft should go in. Right now, my batteries are dead. I'm charging another one, but so essentially what I would do is I put the top back on, and then I would unwind it and check for continuity on pins 4 and 5. And if I lose continuity when it comes all the way in, I know that it's in the unlock position, and you can retest it by pushing it back out. So just to go over the pins again, between 4 and 6 is when it's in the locked position. You want to lose continuity at that point, when the shaft should be approximately 2 7/8 out. And you should lose continuity between 4 and 5 when the shaft is in the locked position. And there is a measurement for that. I forget what it is. I think maybe 2 3/8 or 3/16, somewhere around there. But this is how you assemble and test the rear locker.